Welcome you all to our math class. So today we will discuss some questions of our first chapter, question number 4 and 5, and some extra questions. And before going to solve those questions, I would like to give some hints or some notes how to solve these questions using Euclid's division lemma. Okay, whenever the question is there, just we have to check the b, a equals to bq plus r. So always the value of v is already given in the question in the form of a number, and if we will take that value and put it as b, definitely that question will be solved. But there is a problem sometimes, that number is very big. For example, if in the question some question is there in the form of 3m plus 1, in the form of 3m plus 2, or like that, so you can take b equals to 3. Also there is a question that prove that all the even integers are in the form of 4q or 4q plus 2. You can take also b as 4 because it is given. But the problem is, in some question the value b is 8, 9, 10, 18. So what to do? So if you will take b as 9 or 8, you have to take remainder 0, 1, 2, 3, 4, 5, 6, 7. If you will take the b as 18, definitely the question will be solved. But how much cases you are getting? You are getting 18 cases are from 0 to 17. Okay, so we can try with the values, but if that value, particular b value, the number is little bit bigger, we can try with factors. Okay, suppose 18 factors are 2 are there, 3 is there, 6 is there, 9 is there. So we can try with the factors. It is not guaranteed that if I will take the factors, definitely I will get the answer, but I may have a try. I may speculate which factor I will take, it will be easy. I may have a guess or trial and error method. And the next one is applying Euclid's division lemma on two numbers. It may be 17, 10, it may be 10 and 17. It's always same. Okay, and always the greater number is taken as a. And when we are applying Euclid's division lemma to solve these questions, so one value, numeral value, what we take as b, and the other one already given in the question in the form of a, in the form of n, in the form of p, we take that as a, the algebraic value, and we take the numeral value from our mind according to the question, the numeral value that is given as b. Now we will check the questions of exercise 1.1, question number 4. It is given, use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. See, here 1 point m is given, one integer. So b we will take from the question. So the question is 3m or 3m plus 1, and it is pretty clear that b will be taken as 3. Okay, so now we will solve these questions by taking a as m and by taking b as 3. So let's take two integers a and 3. Applying Euclid's division lemma on a and 3, we got a equals to 3q plus r. So here r is the remainder and its value lies between 0 to 3 and may also equals to 3. So the values are 0, 1, 2. Then we will apply the values of r and we will take it as a case. Means there are three cases, r may be 0, r may be 1, r may be 2. If r equals to 0, it is 3q plus 0 equals to 3q. Then I will calculate a square, that is 3q square, which is 9q square, that is 3 whole into 3q square. So it is 3 into something, that means 3 into m. So this is in the form of 3m. Then we will take r as 1, so a equals to 3q plus 1. Then we will find a square, 3q plus 1 square, then it is a plus b whole square, 9q square plus 6q plus 1. So we have to show it is either in the form of 3m or 3m plus 1. It is 3m, automatically the number will be either in the 3m or 3m plus 1, means only the difference is about the number. So here the number is 1. So 9q square plus 6q, 3 can be taken as common, it will be 3 whole into 2q square plus 2q, and 1 is outside the bracket. So that is 3 into something, that means 2q square plus 2q, let it be m plus 1. So here a square equals to 3m plus 1, where m is 2q square plus 2q. Then we will go to the case 3, where r equals to 2. So a equals to 3q plus 2 and a square equals to 3q plus 2's whole square. So using a plus b whole square, we got it 9q square plus 12q plus 4, but we have to show it in the form of 3m or 3m plus 1. See, the algebraic value or the variable here is 9q square plus 12q. So here 3 can be taken as common, okay, and I need to check the numeral value 4. Is it a multiple of 3? No. So I will break it in such way that I need in the form of 3m or 3m plus 1. So I will break it 1 plus something, and that something is 3. So 4 is broken into 3 plus 1. In the next step, you check 9q square plus 12q plus 3. So 3 can be taken as common. 3 whole into 3q square plus 4q plus 1 bracket close plus 1. Here it is 3 whole into something plus 1, that means 3m plus 1, where m is 3q square plus 4q plus 1. So here it is in the form of 3m plus 1. So we checked it is either in the form of 3m or 3m plus 1. Similarly, we will solve another question. So it is so that cube of any number is in the form of 9m or 9m plus 1 or 9m plus 8. Just from the hints or from the question solved earlier, it is clear that a means the algebraic value will take it as m as given in the question, and b we may take as 9 as given in the question. So applying Euclid's division lemma on two integers a and 9, we will get a equals to 9q plus r, where r equals to 0 to 8. There are different 9 values. Just to think, there will be separate 9 values of r and hence 9 values of m. So after or a. So after getting the value of a, then we will find its a cube of the number. Then we will make it in the form of 9m or 9m plus 1 or 9m plus 8. Definitely we will able to solve the question, but the problem is it is very difficult. So actually in the exam or whenever in a test this question comes, we will not take b as 9. Just for understanding purpose, here I am solving it by taking b as. So in first case, by taking r equals to 0, a we got 9q, then making it cube, it is 729 q cube. Then if I will take 9 common, then something will be there. So it is in the form of 9m. Similarly, in the second case, 9 cube plus 1 cube, just check the formula of a plus b whole cube, it is a cube plus 3a square b plus 3ab square plus b cube, and a cube it is always, as a is 9 means it is 9 cube, a is always 9 cube, then always the cube of 9 cube is a multiple of 9. So 9 can be taken as common. Similarly, the second 3 whole into a square. So a whatever that is 9 cube, that is square, and 3 into 9 square, it is 27. So also 9 can be taken as common. Then the next one is 3a b square. So 3 into a, the first term, it is always 9. Okay, so 3 into 9 27, as 9 is there, also 9 can be taken as common. The remaining, the last term is bq, but here b is, there is no 9. So b is sometime it is 1, sometime it is 2, sometime it is 3, means it is the value of the remainder. Okay, so 9q plus r, so it is varying, so its cube will also vary, but in this case here it is 1, so 1 cube is 1, so it is in the form of 9m plus 1. So what I am trying to say, there are 4 terms in the formula, the first 3 terms are always divisible by 9, so 9 can be taken common, but the last term is not mandatorily multiple of 9. So I have to arrange the last number in such way that either it is 1 or it is 8. If it is not in that one, I have to break it into the sum of 2 numbers such that one is 1 or 8. If it is 1, then it is okay, 9m plus 1. Okay. If it is 9, then 9 can be taken as common, then nothing is there, 9m form. And if it is, suppose I will say it is 10, No, not 10. Suppose it is 17, for example, it is suppose coming 17. So, I have to break it such way that either 1 or 8. So, 17, 1 plus something, it is 16. 16 is not a multiple of 9. But if I will break it 17 as 8 plus 9. So, 8 I needed in the end and 9 is a multiple of 9 itself. So, similarly, we will check for the all different values. So, when r equals to 2, so b cube is 8, automatically it is 9 into something plus 8. If it is 3, so it is 27, 9 can be taken as common. So, it is in the form of 9m. So, next if it is 4, so it comes to 64. So, 64 I can write 1 plus something or 8 plus something. So, 1 plus something means 63, multiple of 9 plus 1. Then suppose 5, it is 125, then try to separate it 1 plus something means 124 plus 1. So, 124 is not divisible by 9. So, try to write 125 as 8 plus something. So, it is 8 plus 117. So, 117 is a multiple of 9. So, it is taken under 9m plus 8. So, automatically you check that the last term definitely a multiple of 9, or you can divide, you can categorize, or you can convert it as the sum of two such numbers. One is 1, other one is a multiple of 9, or one is 8, other one is a multiple of 9. So, this you may try. So, now come to the point that all these explanations is very difficult, I think, for you to understand. Just for understanding purpose, to know something I have explained. Now, we will go to the easier version, how we can easily solve this question. So, as already said to you, so if the value of b, the numeral value, is something greater, then we should look after the its factors. Just like in this question, it is 9. So, 9q, it is very big number. There are possible different 9 values from 0 to 8. So, when I will check its factors, so 9 has the factors 1, then 3, then 9. So, 1 is not possible. So, I should take 3, and here also there is another explanation in this slide. So, one explanation is there. If b is 1, then b cube is 1, not a form of 9m. If b equals to 2, b cube is 8, not in the form of 9m, means 9 into something, not a multiple of 9. But if b equals to 3, b cube equals to 27. So, here it is 3 into 9. So, in the form of 3m. So, I should take it, because 3m, when I will make it cube, it will be 27 and definitely a multiple of 9m. But simply you can think, accept all these verification, simply you can try which number is there, try its upmost, the greatest factor. Okay, accept that number, means here 9, forget about 9. Next, what is the greatest number? It is 3, then you can try 3. If the question it is 8, okay, so 8, accept 8, next factor is 4, you can try with 4. But now in this question, as 3 is a factor, let us take the numeral 3 and applying Euclid's division lemma on a and 3, it is a equals to 3q plus r, where r is less than equals to 3. So, possible values of r equals to 0, 1, 2. Then there are 3 cases. If r is 0, a equals to 3q, then a cube equals to 27q cube, then it is 3 whole into 9 cube into something. So, it is 3m, it is in the form of 3m. If r is equals to 1, a equals to 3q plus 1, then a cube equals to 3q plus 1's whole cube. Then putting the identity, I am getting something that first 3 terms are multiple of 9. So, taking 9 as common, I are getting 3q cube plus 3q square plus q plus 1. So, it is in the form of 9m plus 1. Taking r equals to 2 and a equals to 3q plus 2, then a q equals to, using the identity, I am getting 27q cube plus 54q square plus 36q. As already discussed, the first 3 terms are multiples of 9. So, taking 9 common, so I am getting 9 into something plus 8. So, this is in the form of 9m plus 8. See, question is very simply solved. So, always take the value, numeral value as given in the question, but if it is a greater one, then take its factors, and always the greater factor is possibly more correct. Then there is another important question. This is not from the exercise, this is from the practice questions, and also I have put it in exam. So it is your 12 number question in exam. So that any one of n, n plus 1, n plus 2 is divisible by 3, where n is a positive integer. Very simple, n is a positive integer. So 1 is n, another number is 3 as given in the question. 3 is very lesser one. So n and 3, applying Euclid's division lemma on n and 3, I am getting n equals to 3q plus r. So where r equals to 0, 1, 2. Then if r equals to 0, n equals to 3q plus 0, the value is 3q, and you can check 3q means 3 into q, means 3 into something. So it's divisible by 3. Next one, 3q plus 1. So here 3 can't be taken as common. Next, n plus 2, 3q plus 2. So here 3 can't be taken as common. So only 1, 3q is divisible by 3. Case 2, if r equals to 1, then n equals to 3q plus 1, 3 can be taken common, n plus 1 equals to 3q plus 1 plus 1, it is 3q plus 2. Also 3 can be taken as common. Next, n plus 2, so n here is 3q plus 1 plus 2. So the total value is 3q plus 3. So here 3 can be taken as common, and 3 whole into q plus 1. This is 3 into m. So third one, that is n plus 2 is divisible by 3, but the first two are not. So case 3, r equals to 2. So if r is 2, n equals to 3q plus 2, 3 can be taken common, n plus 1, 3q plus 2 plus 1, 3q plus 3, yes, 3 can be taken common, that is 3 into q plus 1, that means 3 into something. So n plus 1 is divisible by 3. And the next is n plus 2, that is 3q plus 2 plus 2. So it is 3q plus 4, and here also 3 can be taken as common. 3 can be taken as common from 3q plus 3, so it will be 3 into something plus 1. So it is not a multiple of 3. So from these 3 cases, it is clear that, so from the 3, n, n plus 1, n plus 2, always only 1 is divisible by 3. And there is also an alternate methods. Many of you have tried in our exam, and I am attaching one photocopy of that. You can check. That method is also correct, but the last paragraph some of you are missing. You should write the last 2 to 3 sentences. That's very important. With this, just I would like to summarize this with one more question like this, something like this. It is out of 3 consecutive numbers, n, n plus 1, n plus 2, only 1 is divisible by 3. And the another question like this was, the product of 3 consecutive numbers, n plus 1, n plus 2, n plus 3 is always divisible by 6. You can solve it also by taking appropriate values. So divisible by 6 means, so we will take the b as 6. So a and b, a is a, b is 6. So you will find it, and you can also try it with taking the b as also 3 as a factor of 3, and you will multiply, always something will be common. If you will take b as 6, it will be lengthy, but if you will take b as 3, you will also get the answer, but it will be very short. So take b3 and solve these questions. Okay, and by taking b as 3, you will get n, n plus 1, n plus 2. Whenever you will multiply these 3, always you will get 6 as common. Okay, so this will be divisible. So this is all. Thank you all for listening. Thank you.